Hello and welcome everyone to another Pure Systems webcast. My name is Robert Hellebrand and I will be your moderator for today's session, in which we will cover how holistic product line engineering simplifies product development in the automotive industry. Our speaker for this session is Shivani Hegde. As a field application engineer, Shivani helps our customers to get an initial understanding of product line engineering with pure variants and supports them in their transition from ad hoc reuse to systematic and holistic or reuse approach. This webcast today is the third and last one in our series called Mastering Holistic Variant Management in Engineering. If you missed one of the previous episodes or just joined this time, you can still find the recordings on our Pure Systems YouTube channel. Make sure to check out the webcast section of our website, Pure Systems, pure-systems.com, for upcoming Pure Systems and partner webcasts. The next one will be a webinar hosted by IBM on the topic Engineering Sustainable Products with IBM ELM and Pure Variants on September the 28th. So with that out of the way, I want to hand over to you, Shivani.
Thank you, Robert, and welcome everyone from my side as well. So now let's get into the topic. Let's first understand why holistic product line engineering is important and what are the current challenges that the customers are facing. So as we all know, the automotive sector is renowned for its complexity, with the products ranging from various vehicle models to intricate subsystems. As you can see in the image here, these are the different components used in vehicles for different model productions. Thus, this complexity often leads to challenges in managing variant-rich product lines efficiently. And the next point is that we ourselves would have witnessed, if you look at the cars that we use now compared to the earlier ones, right? The use of software and electronic components within the vehicles have drastically increased. So it could be from your rear view cameras to cutting edge multimedia displays or even advanced safety systems like the airbags. So it all has kept improving. So as the demand for customization and innovation continues to rise, the automakers are confronted with the need to address these challenges more effectively. Next is the pace of the software development happening. So it has escalated dramatically as well. So with the iteration cycles now measured in weeks instead of months. So this accelerated pace introduces a fresh set of hurdles in managing the variability in engineering assets. And when I say engineering assets, it could be anything. It could be your requirements, it could be your code, architecture, and testing, and so on. So it is hard to manage this variability, and at the same time, it is very essential to generate a validated and a reliable product variant. So having said all of these challenges, what comes to the rescue is the holistic product line engineering. So holistic product line engineering offers a comprehensive solution to these issues. So with this approach, automotive companies can harmonize their product development efforts across the entire spectrum of vehicle models. It could be a components and features. And this methodology not only enhances the development speed, but also promotes consistency and reduces errors in the development process. So now, since we had a look at the challenges, let's go to the next part, that is the concept. Let's understand what we mean by product line engineering with pure variants, that is our variant management tool. So one thing I need to first mention is pure variants completely compliance with the ISO standard 26580. This is the standard for feature-based product line engineering. And now coming to the concept. So as you see, we have this feature model here. So feature model is where you can express your commonalities and your variabilities efficiently. And it captures all the features and the relations that exist within your product line in the form of a feature model. And this feature that you see on the screen, we have the feature model of a functional feature of a front car light system. And there are different features here, right? And each of these features are mainly created, like, it depends on your product context and how the stakeholder would like to represent their product line in the form of features, right? So here we have 4 feature types. So that's how you manage the variability. So first one is, you see the mandatory feature, which is represented by an exclamatory mark. Then you have these alternative features, which means that either one of them should be selected. You have the optional features, which is represented by a question mark. 0 or n number of features can be selected. And then you also have these or features, meaning at least one of the features has to be selected. So this way you create all the features, giving them each feature type. Moreover, you can also have relations among your within the features, or across cross-tree dependencies, that is across different feature models. And there are different kinds of relations that you can have, and one such is the requires, and also you can have attribute values, which can be of type integer, strings, and so on. So now that we've spoken about the feature models, let's look at the next part, that is, or the next block, that is the domain assets. So you have your feature model in one hand, and then you go to your domain assets. By domain assets, what we mean is that it's your 150% requirements, 150% superset document. So it could be your requirements, or it could be your test cases, it could be your architecture models, and so on. So on your screen, what you see is the requirements module. And this column basically represents all the requirements. And next to it, so you see this column, right? This is the PV restriction column. And here we add in the feature-based rule. So using this restriction or these feature-based rule, we are basically doing the mapping between the domain assets and the feature models. So you see, these are the features that are basically taken from the feature model that we've expressed in the form of a rule. So once we've done that, then, so yeah, this entire part comes under domain engineering, which is important because now in the application engineering is where we are going to start configuring our variant, our product variant. So that's where we do it in the variant models. So you see here, right? So this is the extension is VDM, and here it is different from the feature model because here you have these square boxes where you can make the features, or you can select the features by just selecting it, or just taking or excluding the features. So basically, depending on which feature you would like to have in your product variant, you are going to configure it in the variant model. And once you have done that, then you finally want to have your 100% asset, right? Your final product. So that you do by triggering a transformation. So later on in the demonstration, we will see how that is done. So we have configured a model, then we trigger the transformation, and then you see we have a reduced set, or the 100% requirements document. So here in this slide, we have only spoken about the requirements document. It could be your architecture models as well. So if you notice, this is a reduced set because you had specified the rules next to each of the requirements. The rules are validated, and if it goes to true, then that particular requirement is taken and considered in your 100% variant. So this way, this is the concept of product line engineering. And if you consider this part, that is the feature model and variant model, that comprises, that basically falls to, or you can call it as your problem space, where you work with the pure variants, and the other one is your solution space, that could be your any engineering asset, requirements, architecture, and so on. So I hope it gave you an idea as to what exactly we mean by product line engineering with the pure variants. Now let's have a look at the next part, that is holistic product line engineering. So we kept telling, we kept using the word holistic. So what we basically mean by that? We say holistic because pure variance comes with a full support, or it's a full tool support throughout your development, throughout all the stages of development. So you could be anywhere in your development life cycle. Pure variance has a solution, or would help you out in managing the variable in that particular stage. So thus the impact of it is obviously consistency. Next is efficiency. So why do we say efficiency? So imagine you are creating a range of vehicles. So from commercial city vehicles to robust utility vehicles like the trucks. So each of these vehicles, as we know, have their unique requirements, design, and even the software commands are different for each of these vehicles. Just imagine how would it be without a holistic approach, right? So without a holistic approach, you would have to configure the specification for each of these model over and over again. And that's why product line engineering has a central place that helps you manage all the differences between your car models, which we refer to as the variability information in the feature model. So you see, this way, feature model is then connected to all the different stages of your car's development process, ensuring that they come together, whether if it's a commercial car or even a truck. So it keeps track of all of it. So that's why we can do it efficiently. Next, cost reduction. So now, since we are reusing the components and assets, definitely there is a huge reduction in the development cost, and also this accelerates the time to market, right? So this way we have a definite cost reduction. Then flexibility. So since we can adapt quickly because we are reusing, there's no much time taken in the production of those vehicles, you can adapt quickly to changing customer demands with the product line's ability to create and manage diverse product variants effortlessly. So another point also that I would like to mention here is, maybe now the products are being developed for an international market, right? So in that case, they must adapt to different rules depending on the cultural or the legal requirements. Those are the rules that they must abide. So thus, with the product line engineering approach, it also gives you that feasibility to do it as and when you want. So now, having spoken about flexibility, let's look at the last point, that is the quality optimization. So many of the OEMs want to be able to make a good quality product. They want to price them efficiently, or price them really well and release them at the right time. So, and this is possible with the holistic product line engineering because it efficiently manages your variability and reuses the assets across your product line in a very easy way. Right? So that is why we say holistic product line engineering. And in turn, these are the benefits we get when we start using it on a long run. So now we spoke about the challenges, we saw the concept, we understood what we mean by holistic product line engineering. Now let's take a industry use case. One industry use case that we worked on, and we would have a look at it on how we've done it. So before that, let's have a look at the problem statement. So you see, in the context of automotive company, like I said, we have a diverse array of product lines, right? So let's consider a product line of cars, which is then further divided into sub-product lines. In our case, in this use case, we divided into, they wanted it to be utility vehicles and commercial vehicles. All right. So once you have further divided into sub-product lines, going further, these sub-product lines would again in turn want to have variants, different variants, because for there are different features, right? There would be some kind of tweaking or some changes that each variant would have. So thus there would be different variants under utility vehicles and different variants under commercial vehicles. So how we do that is, in this particular use case, we have either reused, or you can also inherit or even reserve some features for future consideration. So now in the next slide, we will see how we have best approached the idea of sub-product lines, for which, as you see, we have different features and components depending on the kind of vehicle you want to configure or produce. So yeah, so now this was the problem statement. And next, let's look at the solution. So here you see we have these solutions. For this, again, I'm stressing, for this particular industry use case, we have used cloning and inheritance. So mainly cloning for utility vehicles and inheritance for commercial vehicles. And now we'll see why did we do so. Okay, so first let's understand what we mean by cloning. So cloning is basically, so with our tool, Pure Variants, you can use the concept of cloning by, you can just create new variants by copying the feature selections from an existing variant. So we will also demonstrate it, how we did it, but this is what cloning basically means. And it's preferable for utility vehicles in this particular use case, mainly because the criteria for suitability that we had considered is this acts as a common starting point with the flexibility to do any tweaks or changes to the existing decisions. So once you clone your variant, even after that, you want to change your features. You maybe want to add a new feature to that particular variant. Even that is possible. So thus, for utility vehicles, we've used cloning. Next, we have inheritance. So what is inheritance? So you see, with inheritance, you can derive variants by inheriting it from a source variant. And here in commercial vehicles, we made use of inheritance mainly because you want to have a common base. That is to make sure that is there is a lot of common features between your different variants, and you want to have the ability to introduce changes to a lot of different variants in a consistent way and at the same time. So that's why inheritance helps you, because the parent, if you just do a change in the parent VDM, then those changes are automatically propagated to all the child variants at the same time. So it makes your task much easier, because you don't have to sit and configure every other variant, even though it's just one small change that you want to have, right? So therefore, here inheritance was a more suitable way. Again, I'm telling that in other OEMs, they might use inheritance for utility vehicles as well. So it basically depends on your product context. And in this industry use case, this is the reason why the customer picked cloning for utility and inheritance for commercial. And so these are the two functionalities that we use. But for completeness and just to make you all aware, that I would like to also say that Pure Variants, the tool, supports partial configuration as well. So this is basically used in other industry cases and OEM contexts. So mainly for the following reasons, because in yeah, so now just imagine what exactly partial configuration is you have a generic pool of reusable assets. So that is your 150%. And from there, you generate your sub-product lines for maybe your production series or a model range. And this sub-product line would consist of a reduced feature model and reduced domain assets. So You can also call this sub product line as your 120%, mainly because it is slightly reduced, but it still consists of all the variation points. And then you going further, you configure it in the next step. So this is how typically it is used for instantiating product line for product series. As we mentioned here, it is preferable for that. And like I said, criteria for suitability is if you want to instantiate the sub product lines for the purpose of stepwise configuration of variants. And yeah, stepwise reduction of variation points in the engineering assets. So these are the solutions or the functionalities that Pure Variant supports. Next, let's have a look. Yeah, we'll have a look at the demonstration on how exactly we do it. So let's dive into the tool. But before that, I would just show you all a workflow so you'll have an idea when I'm going through the demonstration on how exactly it's done. So here you see, yeah, just a minute. Yeah. So you see you have this, So you see you have this generic platform that is your product line. And the idea is that for this generic platform has the feature models. So now we are considering our use case where you have the functional feature models, then you have the regions feature models, utility feature model, and the commercial feature models. And this generic platform or your 150%, it consists of the 150% assets as well. And here in this use case, we have used Polarian as a requirements management tool and Cameo as the architecture or MBSE tool. Then you have your variant model. So what we did was we considered all this. Then we started configuring the variant model for commercial and for utility. So once we configured that, then we triggered the transformation. Upon triggering the transformation, we achieved the sub-product lines, that is 100% utility, 100% commercial, and then we went further to have different variants. So we started configuring different variants because we wanted to decide that, okay, this commercial vehicle would have variants where, again, the set of features would differ, right? It keeps changing. So that's why in the next level, you decide to create different variants for commercial vehicles and for utility vehicles. So this is kind of like a high-level workflow of how we go about it. Next, let's see how we do it. First, let's have a look at the feature models. So here you see, this is the functional feature model. And it's a tree-like structure with the different variation points that I mentioned about. Then, so you have the region features in case you want to have different market, satisfy different market demands. Then you have the utility vehicle feature model with its own set of features. And then you have the commercial feature model. So you see, these are the set of features. So these are the feature models. And next, what we have is, once we have the feature models, let's look at the 150% assets. So here you see, okay, so you see, we've taken, as I mentioned, we've taken the Polarian as a requirements tool, and we have added the restrictions. Well, like I said, it is the mapping between your domain assets and your feature model using this restriction field, and this is the feature that we've added the restriction with. And over here on the right hand side, we have a pure variance integration where you have the feature model listed for you. So yeah, so once you have this, and then you can configure your variant. So you see here we configure the variant. So we've added the restrictions, then we configure the variant, and then we can go back to the 150% asset or the Polarian tool, the requirements tool, and even have a preview. So this is a functionality that Pure Variant supports. So you can see, you can switch between your variants, and simply by just clicking on that drop down, irrespective of how many variants you have, you can select a variant and then click on this preview icon, and it would show you a preview of what kind of output to expect. So this way it makes your job much easier even before triggering the transformation, that you have the preview functionality. And now you see we've done it for utility vehicles. We start configuring it, and here, like I said, MBSC tool that we considered was Magitra or Cameo, and here the variation points are expressed in terms of that small symbol that you see with a V, the blue mark, and you have these feature-based rules within it. So once you have these feature-based rules, and then you have configured your variant, even in Cameo, you can have a look at the preview. So you see, this is a Pure Variants integration within Cameo. You simply select your variant model, click on the preview icon, and here it would give you the preview of the what kind of output expect. So in this case, you see the red ones means they're not going to be part of your 100% variant, whereas the green colored blocks are going to be part of your variant. The boxes that are the blocks that are not colored means they are the common blocks and are going to be part of every variant. So just to go back, I don't know if I mentioned this point, but in Polarian, when you click on the preview icon, right, the requirements are grayed out. So just in case I've not mentioned, but that's how we get to know if the requirements are going to be part of your 100% variant or not. So now we saw the preview. Yes. Now we configured our variant, we saw the preview. Now let's derive our variant specific output. So how we do that? So as you saw, we just before triggering the transformation, because we have told, or because we are focusing on the point of holistic variant management, right? So you can configure or trigger the transformation and have both your 100% output, even though it's your 100% requirements document and your architecture model at the same time. We see how we do that. So you go to your configuration space, you go to properties. Here you can select the family models. As I mentioned earlier, family models are the ones into which your engineering assets are included. So now we are going to select the Magic Draw family model, because we are working with that tool for MBSC purpose. And then we have the system requirements. That is, your Polarian assets are basically within this. Then what we do is we have a variant with us, the commercial variant. And then you have this icon here at the top, transformation icon, right? So you just have to simply click on that, and we have already configured added the Polarian module and the Cameo transformation module within it. And just by one click, you can trigger the transformation, and your 100% variant or your 100% requirement specification document is generated for you. So here you see, in case of Polarian, we have triggered the enum transformation, that is the tag transformation, and that's why each requirement has a part of each requirement is tagged with the name of the variant, and this requirement is not part of this variant. So you see, because we triggered for commercial, this requirement is part of it. So, and this way you can also have a look at the Cameo side. Here, this is your 100% architecture model. So you see it is reduced, right? So there are most of the blocks are not there because those restrictions had evaluated to false, and thus this is your 100% architecture model. So this way we do the transformation and have a 100% document. And then now let's have a look at the cloning, how we do the cloning. So because we've generated a sub product lines and now we want to have different variants of it, right? So let's see how that's done. So we have a utility variant model. So you see, this is a variant model because it's one way you can differentiate is with those square boxes that you see. And these are the selections that has been done within it. And then you just have to right click on it. You select clone, give it a name. First, select the configuration space into which you would want to have it in, and then here. So this is what we meant. So you see, even though you have done certain decisions here earlier, and then you want to change it, you can easily do it. So this side is your cloned, on the right hand side is your cloned VDM, on the left hand side is the one you cloned it from, and here, independent of this model, you can do any kind of changes in your cloned VTM. So this is one of the main reasons for using cloning, and in our case, we used it for the utility variant model. Next, let's look at the inheritance. So here you see we have the commercial variant model. We have done a configuration in this variant model. How we do the inheritance? Let's have a look. So we right click and we go to new. Here we click on the variant model. We select the config space and then we name the variant model. So in our case, we've named it commercial vehicle inherit. We click on next, and in this section is where you want to select. So it could be any other model as well. So in our case, we want to inherit from a commercial variant model. So we select the variant model from which we want to inherit. And as I mentioned here, in case it was partial configuration, you could have gone here. But in our case, we would just go ahead with full configuration. That was done in this use case. And we just, select finish. Yes. So now you see these are the two models. So on the left hand side again is your original or the parent model. Right hand side you have the inherit model. So it doesn't matter how many variants you have, how many child variants you have. You just have to make a change here in your parent model, and you see the change or the selection is automatically propagated into the child models. And also this lock symbol. So if you notice, even before, some of the selections already had a lock symbol, right? Because these are the selections that was inherited from the parent model and exist in the child model. So this way you can use inheritance to do any changes with just one click. Yeah, and yes. Now, after having said this, so we saw all of it. Let's just, before ending the session, let's just quickly do a recap of what all we covered so far. Yeah, so like I said, we had a look at the holistic product line engineering. Pure Variants comes with a full tool support throughout all your stages of product development, and we have connectors for requirements management, MBSE, and so on. Then cost and quality optimization is what it gives us, because you're reusing your assets, you reduce the development costs, you can deliver good quality products, and you can release them just in the right time. The solution that we used in this particular use case was cloning and inheritance, mainly because you can have the flexibility of overruling any existing decisions. Inheritance, because you mainly want to propagate by just doing changes in the parent VDM, and then even though there are 100 other variants, you just want to propagate it automatically. And finally, partial configuration is what we said we support, and it can be used in combination with inheritance and cloning. So this is all from me, and now I would like to hand it over to Robert.
Thanks, Shivani, for introducing the audience to product line engineering, explaining the concept, and then going to a typical case, and connecting the dots on how different capabilities that have been implemented on the pure variant side and certain concepts that are available there can help to tackle challenges that are faced and to work with those use cases. and or to make them work. We will now have a look at your questions. You still have the chance to ask questions via the chat. Don't be shy, only the moderators will be able to see them. And if you want to go deeper in discussions with us, maybe Shivani, you can show the next slide.
Yes, yeah.
How to better understand the value of product line engineering and provide that it can provide to your company. Or if you want to get more detailed presentation on one or multiple of the connectors that are part of Pure Variance Enterprise, don't hesitate to reach out to us via the contact form on our website, via email, or via LinkedIn. So let's have a look at the questions tab. So, and I see we have multiple questions. Yeah. One is whether we can, and I can say the answer to that is yes already, whether we can share the example Pure Variance project. Yeah, so we are using our Carlight example typically for the demonstrations like we did today. And yes, on request, we can share it. So yeah, you will receive a personal message, yeah, and we will organize that. Also, another question is regarding cost reduction with Pure Variance. When is the break-even point after introducing Pure Variance? How can I measure that? So, good questions, yeah. And so the answer is not so simple to that. So we have that I can say. Let's start with the second question. We have customers who measured that, and what exactly they were measuring was the lead time, yeah, for new product variants. So that was one thing where it could be measured heavy reductions. Yeah. So from the second variant on, yeah, the first one you basically it's like your first product that you develop. Yeah. But from the second variant on, you can make use of these reuse mechanisms to be faster regarding time to market, and also cost reduction was measured there. So this was done via measuring the effort going into coming up with a new variant. Yeah. So for the initial coming up with it. Yeah. What you can then measure over time is, of course, also the efforts for maintenance. Yeah. So if you are currently and for most of our customers, it's the case they are currently already providing products and maintaining them. If you're currently doing that, you can, and you have current numbers, you can compare them with the numbers you achieve when you introduce product line engineering. And you don't have to wait till you fully introduced it in a holistic way, yeah, like Shivani showed today, also that you connected the feature model to all of your engineering assets, even if you are going for a stepwise approach, introducing PLE step by step, maybe starting on requirements level, then going to the architecture, then going to code, going to simulation models. You can, when you are done with the first step, you can already start measuring how you improve with those points on that level. Another point, and there's even a public material for that available, is that customers measured improvement in quality. So there, the introduction rate of new errors was measured before and after introducing PLE, and there was a significant reduction of that. Yeah, so much less new errors were introduced into the product line while it evolves, as the variability is handled much more systematically in this way. And so if you want, PM me, I can send you a link to that paper. Then there's another question, and I think now we already partially answered it. In the presentation title and when introducing the concept, you emphasize the term holistic. Which other engineering assets besides requirements and architecture models can be variant managed by Pure Variance?
Okay, so here you can also manage, like I think I kept mentioning it, test cases, or it could be your safety, functional safety tools. So for that, we have the Made-in Analysis connector, Pure Variance connector for it, or also even in case of change management, so Jira. So we have connectors for that as well. So it's across your product development lifecycle. So there are other connectors as well that you can connect it to.
Thanks, Shivani. And coming back to the first question, I see I didn't fully maybe answer it. The question was about reaching the break-even point. Yeah. So I started talking about measuring certain KPIs. By measuring that, of course, then you can figure out when you have reached the break-even point. Yeah. And by experience, so I can tell you that the numbers we get reported that have been measured in existing projects, yeah, were quite impressive. So ranging from reduction of effort from 40 to more than 80%, yeah, for for the creation of new variants compared to doing this without a PLE approach, and similar impressive measures regarding the introduction, the lead time reduction, yeah. So if you can translate that to the effort and to your scenario, what would this mean in numbers, also in money for your company, and then compare it to the introduction costs you see, yeah, which depends on the scoping you initially take, or whether you go for a big leap for PLE, or whether you do this step by step and want to know when did I reach the break-even point for that specific step, then you have the right numbers to answer your question. I hope that helps. If not, happily, we are happy if you reach out to us again, yeah, and we can follow up that in a direct discussion. Okay, I don't see any additional questions, so this means we are reaching the end of today's meeting. Oh, there's another one incoming, so I will take the chance and answer it. Yeah, it seems like can do everything in pure variants regarding variant management. What use cases are not covered or difficult to execute with pure variants? So happily will also answer that. Fair question. So we come from the area of variant management on system and software side. So there we have a lot of out-of-the-box connectors, like you saw today in the demonstration for Polarion, for example, or for Cameo. Yeah, also for other engineering tools of those categories and others. Where we are not directly connected up to now, so where we don't have an out-of-the-box solution, is the PLM side, yeah. But we know that all of our customers actually are not only producing software or developing software, but they are developing and producing products consisting of software and hardware, yeah, of physical parts and of the software in the end, and that you also have to ensure consistency and reuse across both sides here. So here we can we cannot help with connectors out of the box, but we have experience out of customer projects to connect both worlds, yeah, to help connect the variability models on PLM side to the feature models on pure variant side. And we are also in constant exchange with PLM vendors as well as with our customers to come to better answer here in future. Yeah? For now, the answer is we have experience making the connection there, but not with an out-of-the-box connector. Yeah? So that's when you ask about where is an open point there. Okay, so with that, let's come to an end. Yeah, thank you for for participating in today's event. Thanks again, Shivani, for being presenter today, and we hope to see you again and hear from you in another webcast. Thank you.
Thank you.
Goodbye.
Bye.